The first images of Earth from space gave us a new perspective on our place in the universe. Our blue planet suddenly looked small, surrounded by the thin layer of atmosphere protecting all life from the hostile environment of space. As satellites have improved, we have learned about our planet in detail. We know more about how the air and water we depend on for life move and interact. Using data from space and from the ground, we can use computer models to simulate our environment and forecast how it might look in the future. This information can help protect us and our planet. ESA satellites observe the Earth for science and research. Older satellites like ERS-1, ERS-2 and Envisat have been followed by the modern Earth explorers. New missions test new technology to understand the planet. Europe's Copernicus program monitors the environment every day and brings valuable information quickly from the Sentinel satellites. Data from space and improvements in computer power mean we can predict weather better than ever before. ESA developed the Meteosat series of satellites to watch from the 0 degrees line of longitude all day, every day. METOP travels around Earth pole to pole at a much lower orbit and delivers information on temperature, humidity, and trace gases in the atmosphere. From space, we see huge tropical cyclones when they are still far from land. By combining measurements from space with measurements from the ground using modern computer power, we now understand the atmosphere and weather much better. This information can be used to warn people who might be in the path of severe weather. With the help of space data, weather models can even predict storms before they develop. Knowing when and where severe weather will happen helps emergency managers to prepare. Climate change means we can expect more of these extreme events, and we will need to be ready. ESA has developed satellites to measure all sorts of different parts of the environment from space. We have learned about how our ice is changing, how land is being used, about air pollution, and even the shape of Earth's gravity field. Data from space turns to valuable information on the ground. We can tackle the complexities of how everything is connected, of how our planet works as one system, and how climate change is altering the delicate balance of Earth's natural processes. ESA works with the climate science community to look at particular elements of the climate system, such as greenhouse gases, ice sheets, glaciers, sea level, and biomass. At ESA's Center for Earth Observation in Italy, records from European satellites carrying a range of different instruments go back more than 30 years. They are re-examined regularly to find new information. Scientists use a process called reanalysis to be certain of exactly what data each instrument recorded and when. Sometimes this means going back and talking to the people who built sensors for different wavelengths and figuring out how they compare with spacecraft from different decades and different countries. When all of this detective work is complete, the information can be added to the climate record. Sometimes satellites built for a particular purpose can provide valuable information about something else in the climate system. Governments from all over the world work together through the United Nations to try to measure climate change and limit its effects. More than 50 key measurements, known as the essential climate variables, are monitored to show the changes that are taking place on our planet. Many of these measurements rely on data from space. Satellites use different resolutions to monitor our planet. Temporal resolution means how often a satellite sees the same place on Earth. This can be very important to observe rapid changes, such as those caused by fires or landslides. Satellites in geostationary orbit, like Meteosat, see the same view of Earth all the time and deliver information every 15 minutes. This is important to monitor rapidly evolving events, such as severe weather. But because Meteosat is 36,000 kilometers away, it does not see in great detail. Satellites like the Sentinels in low Earth orbit have better spatial resolution, which refers to how much area on Earth corresponds to one picture element or pixel in an image. Knowing the spatial resolution of an image is very important to understand the size of the object or phenomenon being observed. The third important resolution is spectral resolution. Our eyes can see visible light, but we can build satellites to sense light at many different wavelengths. Infrared light is good for observing vegetation, while we use microwave radiation to image objects that are not illuminated by the sun. ESA builds satellites to collect particular kinds of data. Scientists interpret the data to create information we can share. In the end, it takes collective effort to use that information to protect our environment and improve life on Earth. ESA supports climate science through the essential climate variables. The agency is also active in case of natural disasters or accidents that need imaging and other support from space. Satellites are also used to support the United Nations Sustainable Development Goals. From space, we can find out important information about food security, access to water and energy, and protection of our seas and our land. These data can help support responsible use of global resources and a fairer future for all of us traveling on spaceship Earth. Earth observation has given us new ways of seeing our home planet, opening our eyes to the ways we can improve life on Earth.
As a world leader in observing Earth from space, ESA is dedicated to developing cutting-edge technology to further understand our planet, improve our daily lives, support effective policy making, and benefit businesses and the economy. To ensure that this continues into the years ahead, ESA Discovery and Preparation supports early and unconventional research into how space can be used to monitor Earth's surface. In the early 2000s, via Discovery and Preparation, ESA explored the concept of a mission to monitor soil moisture, which ESA later developed as SMOS, a mission to investigate sea ice, which ESA developed as Cryosat, and a mission to find out more about gravity using a novel technique, which ESA developed as GOCHE. Discovery and preparation studies have also been important for the Copernicus Sentinel-1 and 2 missions. Sentinel-1 sends out pulses of radio waves to create very detailed images of Earth's surface below. Several discovery and preparation studies have explored how this technique can be used to find out more about Earth's surface, for example to study tectonic plates. Other studies looked at how data from Sentinel-1 and 2 can be combined for crop monitoring and disaster risk reduction. Looking to the future, Biomass, which is due to launch in 2022, will provide crucial information about the state of Earth's forests. Biomass will peer through a charged region of the atmosphere. This will impact the quality of the images it takes. Recent studies mapped this charged region over Southeast Asia, South America, and Africa to help Biomass take the best possible images. A couple of years later, FLEX will head into space to map vegetation and investigate photosynthesis. As well as being heavily involved in the design of FLEX, discovery and preparation supported studies that explored specific ways for the mission to assess photosynthesis and find out more about vegetation. Discovery and preparation continues to study the feasibility of new missions to monitor Earth's surface, as well as to perform blue skies research to ensure that missions are unique, innovative, and successful.
For ESA's Earth observation programs, the 1st of March 2022 is a special day, as it marks the 20th anniversary of the launch of one of the most important European Earth observation satellites ever, ENVISAT.
ENVISAT is the father of all the missions we have. It had such an important legacy in Earth observation, and we still have it today as a reference model.
ENVISAT was developed during the 90s as a research mission and succeeded ESA's ERS missions. It was built to monitor the health of our planet, using a range of different instruments. In the spirit of the day, ESA chose to develop one large and versatile satellite with many different capabilities instead of a series of smaller, specialized craft. And it showed. ENVISAT, which was approximately the size of a bus and weighed over 8 tons, is to this day the biggest Earth observation satellite ever launched.
ENVISAT was by far and still by far the biggest Earth observation satellite that we ever launched. So at that time we needed basically the biggest launcher, and it was already Ariane 5.
ENVISAT carried 10 different innovative instruments to provide measurements of our atmosphere, land, oceans and ice. These instruments included a radar, an altimeter and several optical and infrared instruments. Whether they were totally novel or improved versions of earlier instruments, all were at the cutting edge of technology, revealing new insights to our home planet and how it is changing.
You see, we have seen so much with ENVISAT that I barely remember. But already in the commissioning phase, for example, using the SAR imaging instrument, which can see through clouds or during the night, we saw the extraordinary event. We saw the breakup of an ice shelf in Antarctica. His name was Larsen C. And that was extraordinary to be able to see that, which was difficult to see before with other instruments, particularly optical, because it's often cloudy there or night. But we could see that. I think it was the second month of the commissioning phase and show that to the world.
While ENVISAT was planned to be in orbit for just 5 years, the satellite proved to be extremely robust, and it surpassed its expected lifetime by a further 5 years. Doubling its intended life, the mission ended in April 2012, but its data continue to be used today for research into how our world has changed. ENVISAT has left an incredible legacy, not only thanks to its science data, but also thanks to its technological heritage.
The Sentinels today are very much operational missions, with data flows feeding the users on a continuous basis for a really long period of time. But they're based on the experience, the expertise, and the technology innovation that was actually on board of ENVISAT. And this is very important for all of us, because the legacy of such an important mission is today in everything we do in terms of Earth observation.
Today, even some of the Sentinel missions, which are key to the EU's Copernicus programme, carry instruments that are based on those that flew on Envisat. Besides Envisat's technological heritage, the mission left another very important legacy by way of wealth of data it accumulated over its 10-year life. The satellite circled Earth over 50,000 times, delivering vast quantities of data and images. This treasure trove of data is still being used by a growing science community, a community that the Envisat mission helped to create. Today, Envisat still yields new science, helping us to understand long-term changes and the effects of climate change. Importantly, Envisat paved the way for Earth observation missions and data to be used operationally, improving daily life by, for example, detecting oil spills.
What is very important is that ESA continues to work on innovation, on technology, on advanced mission in terms of testing new technologies in Earth observation. This is really in the remit of what we do, and also to improve the way to promote infrastructures, including the IT, the digital technologies that can help you use the big volumes of data that we have available and make those accessible to the users. That's also part of what we want to do with the Green Future Accelerator, with the digital twin of the Earth, where we will integrate big volumes of data into high computing capabilities and make those available to support not just a monitoring of the state of the art of our planet, but also prediction modeling on climate change and on natural disasters.
Observing Earth from space is now more important than ever, and ESA shows its ambitions to further upgrade space-enabled capabilities for a green future and for rapid and resilient crisis response. ESA continues to monitor our planet, building satellites to deliver scientific and operational data for the benefit of society. Envisat was a precursor to ESA's world-class position as a provider of Earth observation data, leaving behind an impressive legacy and time series of data that will still benefit generations to come.